Okay, we're going to warm up to linear piecewise defined functions. So a piecewise defined function today will consist of only linear pieces, which are straight lines. And we'll be working with pieces that consist of 2, 3, or 4 different pieces. Now each one of these pieces is going to have a constraint that says only graph this piece of the function underneath these constraints. So let me get started as if you don't ever remember learning this in 8th and 9th grade, and maybe that's the case for many of you. This is what you're going to do. We're going to pretend this is simply the equation y equals 3 over 1x minus 4, and I'm going to graph it as accurately as possible. So I'm always going to start here on the y-axis. So on the y-axis, I start at negative 4. The common mistake I saw earlier today is students wanted to start on the x-axis. I'm starting on the y-axis at negative 4, and this is my rise over my run. So I'm going to jump up 3, 1, 2, 3, and over 1. Jump up 3, 1, 2, 3, over 1. One more time, 1, 2, 3, over 1. Now, once I have 3 or 4 points, very lightly, I'm going to connect those points to draw as accurately as possible a graph of that function. Now, I'm going to stop. It does not say in a piecewise function that this piece of the graph should go over the entire Cartesian plane. It says only graph it where x's are greater than or equal to negative 1. So I take this value, which is negative 1, and I go straight down until I find that piece of the graph, which is right here. Now, where are x is greater than negative 1? I tell students, think of this as an arrow. It's to the right. So I only want to graph this piece of the function where x's are greater than or equal to negative 1, which is right here. So I'm going to color this piece in. I want to include that. Now, at negative 1, there's a line underneath. I want to include that piece. Anything to the left of negative 1, which is over here, I just erased. I'm halfway done with this problem. Here's the next piece. Y equals negative 1 over 1x minus 1. I start at negative 1 on the y-axis, and now the rise over the run says drop down 1 and go to the right 1. Drop down 1 to the right 1. Drop down 1 to the right 1, and I can go the opposite direction. Up 1, over 1. Up 1, over 1. Okay, so now that I have my points, I'm going to come in here and I'm going to connect them. And I would say after a few problems, that part students felt pretty good about. What confused them is how do you know where to erase? So I'm going to go to where x equals negative 1, which is right here. And I'm going to draw an open circle. When there's no line underneath, I'm going to draw an open circle at negative 1. So here's negative 1, and here's my open circle. Think of this as an arrow, and it says for this piece of the function, shade to the left. So I want to include this piece of the function as I go to the left. Anything to the right for that piece of the function, I want to erase. The second learning objective today is for you to be able to evaluate this both algebraically, and you can do mental math, and graphically. So let's show here. Let's go f of 0, f of negative 1, and let's do f of negative 6. So the first question we ask ourselves is if we're going to do it algebraically, which one of these is true? Now, I shouldn't have drawn this so deep. There we go. So this is x is less than negative 1. This is x is greater than or equal to negative 1. Okay, is 0 greater than negative 1? It sure is. So to this particular function, I'm going to substitute in a 0. 3 times 0 is 0. 0 subtract 4 is negative 4. That's algebraically how to do it. Yes. Okay, the other way. Yes, you can. I'm not going to stop during lesson, though. Okay, at 0, the other way to do it is I go to 0, and I go straight down until I actually hit a piece of the graph, and look at the y value is negative 4. You can do it graphically or you can do it algebraically. All right, I'm going to go to negative 1. So negative 1, well, negative 1 is not greater than negative 1, but it's greater than or equal to. So again, I'm going to apply this piece of the function. I substitute in negative 1. 3 times negative 1 is negative 3. Negative 3 subtract 4 is negative 7. Now, could we have got the same answer graphically? Let's check. Go to negative 1. This is an open circle. I don't consider it. I go straight down. There's a closed dot, and it's found at negative 6. I must have done my math wrong. Or maybe I didn't graph as accurately as I wanted to. I didn't graph as accurately as I wanted to. That was it. I was supposed to drop down 3. That's why. There we go. Last one is negative 6. Negative 6, well, negative 6 is less than negative 1. So I'm going to apply a negative 6 here. And some of you are going to want to write that down if you like to do it algebraically. 2 negatives make a positive, and 6 minus 1 is 5. Let's check this out. If I go to negative 6, I go straight up. The corresponding y value is positive 5. We're going to jump from 1 to 3. We'll go back and do 2 and 4 afterwards. So let's take a look at this problem. If this is confusing to you, off to the side, just write down y equals 1/2 x plus 3. Let's forget about the constraints and let's just graph this. Remember, when we start by graphing, we always go to the y-axis. So I'm going to start at positive 3. 1, 2, 3. And let's make a dot. The slope, rise over run, tells me from this point I'm going to go up 1, right 2. Up 1, right 2. The more dots you make, the more accurate your graph will become. Take that straight edge, and I'm going to connect these dots. And I'm nearly halfway done with this problem. But there's a constraint here. So how do I apply this? Think of this as an arrow. The arrow says only shade to the right of 1. So let's find 1 on the x-axis, and let's go straight up until I get to that point. Now, at that point, I only want to shade to the right. So I only want to shade to the right of this. This is what I want to keep. That's what I want to keep. The rest of this part I want to erase. Where x equals 1 for this constraint, there's a line underneath. So I'm going to put a closed dot at that particular point. So let's do the next part. I'm going to think of this right now as y equals negative 3 over 1x minus 2. I'm forgetting about this constraint right now. I start at negative 2 on the y-axis. I start at negative 2. The slope is down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. Now I'm going to take my straight edge, and I'm going to connect those points. And now I'm going to apply the constraint. Look at this and think of it as an arrow. The arrow says shade to the right, or to the left, excuse me, shade to the left. So I find 1, and I go straight down in this case until I actually hit this graph. Since there's no line underneath, when I hit the graph, I'm going to make an open circle. And now if I shade to the left, it means I'm only going to shade in this direction. Everything to the right will actually be erased. So I'm going to bring this back up. I'm only going to shade to this direction. So 1, 2, 3, there's 1, 2, 3, and if I darken that in, it looks just like this. And there's my piecewise function. I would like you with your partner to either verbalize by just looking at the graph or doing it algebraically, whatever makes most sense to you. I would like you to evaluate in function form each one of these. So we're going to have f of 1, let's do f of 2, and f of negative 1. Okay, with your partners, go ahead. I'm going to give you 30 seconds, and then I'll tell you how I achieve these answers. Go, 30 seconds. So I should hear talking with your partner. How are you coming up with those? I personally like to use just a visual representation if it's possible. So I'm going to go to where x equals 0. I drop down. Oh, there's the answer. The answer, let me make sure here. The answer occurs at negative 2. So this answer is negative 2 right there. That's my y value. Let's go to positive 2. So here's positive 2. Notice there's no line down below, but if I go right up above, it's right here. And the answer is 4. Now we're going to show you how algebraically we can get the same answers in just a second. I go to where x equals negative 1, and it appears my answer is positive 1. Let's make sure that this is right. So 0. Is 0 greater than 1? No, but 0 is less than 1, so I'm going to plug 0 in. Negative 3 times 0 is 0. 0 minus 2 is, in fact, negative 2. Is 2 greater than 1? Yes, it is. So that's why I'll use this particular piece of the function. What's half of 2? 1. 1 plus 3 is 4. Negative 1. Negative 1 is not greater than or equal to 1, but negative 1 is less than 1. Negative 3 times negative 1 is 3, and 3 minus 2 is 1. I'm going to start by rewriting this. Like, this is just fine, but I'm going to write that down. Y equals negative 3 over 4x plus 4. Now, this is going to be y equals 5. By the way, when you see no x behind the value, that means it's just going to be a horizontal line. I'm going to just give us a little helpful hint. It's going to be a horizontal line. This last one is going to be y equals negative 2 over 1x plus 0. All right, let's get started. So I'm going to start with graphing this very first one. All right, let's get started here. So I'm going to start right now at positive 4. I'm going to do this problem right here. Start at positive 4. Please do this with me. Let's start at positive 4. The slope is negative 3 over 4. That means from here, the rise means to drop down 3, and then we're going to go to the right 4. 1, 2, 3, 4. Let's do it again. Drop down 3, 1, 2, 3, and to the right 4. 1, 2, 3, and 4. Okay, so I have 3 dots. I believe that's enough. I'm going to come over and I'm going to connect those 3 dots just as so. But now I have to apply the constraints. The constraint says, think of this as an arrow. It says, hey, only graph this line to the right of 0. Well, here is where x equals 0. X equals 0 is right here. So to the right of 0 would be just like this. So I'm going to shade this part in. And I'm going to erase everything to the left of 0. Also, at 0, there's no line underneath, so I'm going to make an open circle. We do not consider that as part of the solution to this linear piecewise defined function. Can you give me an honest thumbs up or thumbs down if you understood my first step? It's okay to be a thumbs down. Never be embarrassed for that. Okay, let's do the next one. This part is confusing for students. It's simpler than you think. We're going to go to where y equals 5. So y equals 5 is right here, and I'm going to do this entire line. There's y equals 5. Every point along this line has a y value of 5. But wait, it says to only graph this at 0. It doesn't say less than 0. It doesn't say greater than 0. It says only at 0. So I'm going to come back here. I'm going to erase the left and right, and I'm only supposed to graph that at 0. I'm going on to the last piece of this function. I'm going to graph this. So I'm going to start on the y-axis at 0. And I'm going to go down to right 1. Okay, down to right 1, down to right 1, down to right 1. Okay, got it? And now I'm going to connect those points. And now I have to apply the constraint. Think of this as an arrow. And the arrow says only keep the piece of this line that is to the left of 0. Well, here is 0. So to the left of it is this portion. So I'm going to erase anything below it. Anything below it I erase. Up to right 1. Up to right 1. Hold on one second. Up to right 1. I got a little bit off there. Okay, and here is my line. So I only shaded the piece of this line that was to the left of 0. Notice there's no line underneath. So at 0, I need an open circle. Turning to your partner, I want you to evaluate these 3 pieces for me, please. You can verbalize it if you can see it on the graph. 20 seconds, go ahead. Go to where f, the function has an x value of -1. At -1, the y value is +2. Go to the function f of x, go to 0, and I'm only looking for a closed dot. The closed dot occurs at a y value of 5. Go to where f is equal to, or sorry, where x is equal to 4 for function f, and the y value is 1. This is called a step function. So we're going to start with the very first one. If you're confused about even how to read this, there's three pieces: y equals -3, y equals -5, and y equals -7. Notice that there's no x attached to these values, so these are all horizontal lines that have different constraints for each one. So let's start with the first one. Can everybody go to -3 and very lightly darken in the line y equals -3. Now there's a constraint here. It says only graph the line y equals -3, or this piece of the function y equals -3. Only graph that where x values are greater than -5 but less than -2. So find -2, go straight down. Notice there's no line underneath. So here at -2 is an open circle. At -5 is an open circle. And we're going to shade in between. Everything else is erased. I graphed the function y equals -3, and I only graphed it between -2 to -5. Done. Okay, let's now graph -5. So shaded -5. Now we're only going to graph this piece of the function where x's are between +2 to -2. So at +2, I'm going to do an open circle because there's no line underneath. So there's an open circle. At -2, there is a line underneath, so I'm going to include that as part of the function. I shade in between, and everything else is erased. I'm going to press pause. I'm going to give you 30 seconds to attempt on your own to do the last piece of this step. Y equals -7 will only be graphed from 2 to 6. So I find 2 on the x-axis. Notice there's a line underneath, which means I'm going to have a closed dot. I find 6. There should have been a symbol there. And there's no line underneath, and I shade in between. Now let's practice seeing if you can read this graph effectively. I want to know at -2, at 0, and at +2. So even if you're not done, turn to your partner, not doing anything on paper, but verbalizing what would be the corresponding y values to -2, 0, and +2 for this particular piecewise function. Begin. If you're confused how to do this, I'm going to go to -2 on the x-axis. I do not include an open circle, only the closed circle. The closed circle has a y value of -5. I find 0 on the x-axis. Here's where the function occurs. It has a y value of -5. I find 2 on the x-axis. Not an open circle. I'm looking for the closed circles. Closed circles has a y value of -7.